Okay, before class, you have to tell me like which next topic your teacher start at school.
I was still doing quadratics.
Still quadratic. Okay. So you did the completing square method as well at school or not?
Yeah, we did.
Okay. Is there any problem in that method?
Pardon?
Is there any problem? Is there any difficulty? Any confusion in
No.
understanding? Okay. Okay, then we will do the applications of quadratic equations like last time we just start like this kind of questions if we have something is given in word like word problems are given to us or we can convert that words into our equation. Okay, I think last time we did up to question number 4 and I assigned question number 3 as a homework. Am I right? Do you complete your
Yeah.
homework?
I didn't understand it, so I just left
Okay,
it. I don't understand the word
it's
like
okay.
how to turn a word into a quadratic.
It's okay, no worries. And Isaac, I just want to tell you one more thing. Like after 15 days or after 4 to 5 classes, I will conduct a test. Like in that context, all those
Okay.
things will be included, which we discussed here in this session, or like in 5 sessions, which we will
Yeah.
discuss. Like so, maybe tomorrow I will send you a test on WhatsApp. That test will be about the bearing. Okay, factorization method of
Mhm.
quadratic equation solution. How we can find the solution of a quadratic equation by using factorization method, by completing square, by quadratic formula, and application of quadratic equations. Okay, so we will continue question number 3 here as you did not complete this one at home. So let's practice this one at in this class, sorry, here on the board. So here we have a question. In the word problem, the main thing is that you have to understand what they are saying. Like here, read the statement 2 to 3 times or maybe 4 times, okay, until you are not getting it. Just read it again and again and slowly. The length of a rectangle exceeds the width. Definitely we have two things in a rectangle. We have a rectangle and we have its length, we have its width. They said that length exceeds the width by 7. What does it mean? Let's draw the rectangle so then it will make more sense. Here we have, okay, so if I'm considering the width is x, what is the length then? Length is x plus 7,
X plus.
right? If the area, next sentence is that if the area is 60 centimeters square, how we can find the area of this rectangle? We need to times the length with width, right? And that
Yeah.
is they give us the given us in this question statement this is 60. So now we get the equation. I'm pretty sure as we'll simplify it will become a quadratic equation. Then we will find the value of x. After getting the x, we just have to exceed it by 7 to find out the length. So let's find it out quickly. So it will be x square plus 7x. The next task is not easy. Sorry, it's not difficult. It's very easy. Like here, they did not mention the method. You can implement any. You can do factorization. You can do quadratic formula. It's up to you. If you want to do the factorization,
Yeah.
so you have to implement the techniques. Like here we have a negative, so its pair will not be below this number. It's above this number. 8, 1, 7, no doubt. 8 minus 1, that is 7. Keep this number in your mind and just multiply them. 8 minus 1, 7, no doubt. But product is not 60. Always check out is the product equal to the product of first and last term or not. 8 times 1 will be 8. It's not 60. Then we have 9 minus 2. Why I'm taking away 2? Why not 3? Because I have to keep this number in my mind and I have to make always this number. 9 minus 2, 7. Yeah. 9 times 2, it's just 18, not 60. We are so far away from our pair. At this moment, we just have a 18 and we have to go to 60. So let's skip few digits, a few numbers. So 12 minus, from 12, what should I have to take away to make 7? Definitely 5, right?
Oh, oh, okay.
Now, if we will take 4, so it will be 8. So 12 minus 5, that's 7, no doubt. 12 times 5, it's 60. Yeah, this is the pair. So plus 12x minus 5x. You have to double check always, like, is this true or not? Here, look,
Yeah.
I wrote this thing as it is. I wrote this thing as it is. Plus 12x minus 5x. Is this plus 7? Yes, it is. If I will multiply these two terms, so we will get 60, negative 60 x square. Yes, it is. So then you have to make a pair of first two terms. This is a group of first two terms, and second group. Here we have second group. This is a second group. From first group, we have to take the things common. What can I take common?
Okay.
X. So x will left because there was 2x, x plus 12, and then minus 5 will be taken away from, will be taken as a common. So if we are taking negative 5, x negative 12. Is this true? No, it's not true. Why? What mistake I made here? Can you please tell me? And mostly student made this mistake. What mistake? They wrote this negative as it is. Whenever you are taking negative as a common, change the sign of the both terms. Okay, like here negative, it was a negative, so no, it's positive, and
One.
convert this one into positive as well. No doubt, and you can double check. How you can double check it? You just have to multiply this one inside the bracket, expand this one, and verify, are we getting this thing back or not? Negative 5x, negative 12, negative 60. If I'm marking here negative 12, so it will become plus positive 60. That's not true. If I will expand now, so I will not get back this thing. So it's mean that I'm making a mistake while I'm taking a common. So it's this one must be in positive. I hope you understand my point. And we have many
Yeah.
other ways, like you can check from here as well. Like if we are not getting the same thing, so it's means that uh we made the mistake. Okay. So yeah, let's move on to the next one. Next, what we have to do? We just have to write x plus 12 once, and then x minus 5 equal to 0, and then x plus 12 equal to 0, and x minus 5 equal to 0. Basically, we can implement quadratic formula. Any method you can implement. I told you in the starting, but here I prefer to do the factorization because I already get the um, pair. So that's why I decide to do factorization, because it's a little bit short as compared to the quadratic formula. So this is the answer. We have these two answers, but here negative 12 is not possible. We will not consider it. Why we will not consider? It's not possible. Width will never be negative. Like if you will measure the width of your house, your home, so it will not be negative. It will always be positive. The width, the length of anything will never be negative. Length of length or width of anything will never be in negative. It will always be positive. So it means that 5 is the thing we have. This means that this is a 5. And what is the length? Length is 12. Why 12? Because length
Yeah.
is 7 more. Length exceeds the width by 7. So yeah, and this makes sense. If we'll consider these two values, then the area will also be 60. These are the only values which fulfills the both condition. We have many other condition, values. Like if I'm taking 6 here, I can consider 13 here. Even in this case, you can see length is 7 more than width, but it fails the second condition. Which second condition? The area with these dimensions will not be 60. So we have only one possibility for this, who's like we have for this for those mentioned, we have these conditions, and this condition is also true. Okay, let's move on to the next one. Next, we already did question number 5 in last class. If you want to check, I think I shared the board with you as well on the WhatsApp. Uh, Even in future, like if you need any board, like you want to check out the geometry like bearing, so or factorization method, completing square. So just tell me, I will send you. I will make a PDF again and I will send you. Okay. Like here, last time
Yeah.
with this whole stuff in last class we did. In last class we complete question number 4. You can check it out. This one. It was the same, but here we implement the Pythagoras theorem. Yeah. Okay. Let's move on to the question number 5. Try to solve it. What they are saying. Are you solving it? Should I have to explain it?
Yeah, I'm trying.
It's okay. Okay. If you need help, just let me know. Okay.
Okay.
Inform me when you're done, okay?
Yeah. Yeah, yeah. I think I need help because I don't think this is correct.
Okay, I almost complete here. You can check it out and let me know if this makes sense. If it's not, just let me know again. I will explain in detail.
I got the first three parts or like yeah,
Okay.
but
Okay, next you have to like bring all these things to one side. Okay. On one side make 0, or we can move the things from one side to another. We just have to operate them oppositely. Like if x square was in addition, so on the other side it will be in subtraction, like this. Simply you just need to change their signs. Got it?
yeah.
Next, question number 6. Try to solve it quickly. And I pasted it. Yeah. Yes, what's the idea? I don't think so you are able to solve it. Am I right?
Yeah.
This is a little bit difficult.
Yeah.
We have to consider this one is equal to 68. So it will 2x plus 2 times 26 square minus x square. This is also 2 times is equal to 68. Just take 2 as a common. Okay, let me explain. I just assume let suppose I suppose that width of this rectangle is x. If width of this rectangle will be x meter, then what will be the length? According to
Um,
Pythagoras theorem, this is a hypotenuse. Hypotenuse square is equal to x square plus the length square. This is the length, right? This is a width.
yeah.
I assume that the width is x. If width is x, what will be the value of length? Let's calculate it. Then take the square root. So it means that length will be equal to, is this make sense, Isaac, or should I have to explain in detail up to
Yeah,
this point?
it's making sense.
Okay. After getting the length, I just add all these values to find out the perimeter. You know, perimeter is given to us. What is a perimeter? Perimeter is means total boundary length. Like if I will walk on this boundary, I will cover this length. I will walk on this width, then walk on this length plus this one. So if we'll add all these things, so that will be the perimeter. So I add x plus this thing plus this thing. So that is equal to 68. That's given. So then I notice that x plus x, it will be 2x, and this thing will be 2 as well. And then I just took 2 as a common, x plus root 26 square minus x square is equal to 68 square. Mostly students made this mistake. They cancel out the square with squares. Don't cancel out the square root with square. We cannot do that. Okay, then take this 2 to this side. And this side, what will happen? How this 2 will be behave? Can you please tell me?
Um, minus 68.
Wouldn't be, it will be in division, because on this side it was in multiplication, right? How we can get out of this 2? If we'll divide, so if we are dividing, so we have to divide this side as well. So from this side 2 will be eliminated on this
Oh,
side.
they canceling the two.
Yeah, and yeah, we can cancel out in the next step. So it will become 34. Still, the main confusion is because of this square root. Let's get out of this square root. How we can? Let's take this x to this side. On this side, it will be in subtraction, right?
Yeah.
And I'm just curious, do you understand how I get all these things to this side? This x square was in positive, and here I'm writing negative x square. Negative 14x plus 14x plus 49, it was negative 4. Now I'm writing it as a negative 49. Positive 24, negative 24
Yeah.
is equal to 0. Because I'm changing their place, the position, like I'm changing their side. No doubt, if we'll change the position, like I can write 24 to this side to here and 49 in here. I can change the position, but in that case, I will not change the sign. But as I will change the side means I will bring that value from left side to the right side of the equal. Then I will must change the sign. I will operate that oppositely. So here I did the same thing. I hope you understand it. Now, how can I get out of this square root? Is this make sense? Okay, let me write here.
It'll remain the same.
No, it will not. Like, yeah, as I will take the square root, square on this side. So square and square root will be cancelled because this square root was all on the whole thing, and this square is also the whole on the whole thing. Here question arise like why we are not cancelling this square with this square root, because this square is only on x. Okay, and we cannot combine in subtraction.
Yeah.
Like if we have a square minus b square, we cannot write like this a minus b whole square. No, that's not true. This is not equal. Yeah, if we have a square minus 2ab plus b square, even in that case we have a plus b square. That can be written as a minus b whole square. But we don't have this thing here. We just have a square minus b square. It can a hair square will not be we cannot we are not able to combine this square. If we are not able to combine the square, so we cannot cancel out the square with square root, because this square root is on the whole thing and these squares are not on the whole things. Okay, now we have we are get out of the square root, but on this side we have a square, but we can expand this one. How we can expand? I'm implementing the identity here. There is another way if you want to understand, so I can explain. I hope this
Okay.
makes sense.
Yeah, it makes sense.
This is a little bit difficult question. Okay, let's
Yeah,
choose.
very, very.
Yeah, not a little bit. Like 26 square, what it is? It's 676. 676 minus x square, and 34 square, 1156. And this one will be 68x plus x square. Now let's move these things to this side. On this side, let's suppose 0 is left over there. So 1156, all these things will be written as it is, plus x square. And these things, as we will move to this side, so 676, it will be negative, and x square will become a positive. This x square and this x square. So it will become 2x square and minus 68x. Then we have this one and this one. 1156 minus 676. 1156 minus 676. It's 480. Positive 480 is equal to 0. Here you can implement the quadratic formula or factorization. It's up to you. Okay. We can take 2 as a
Yeah.
common. The first rule of factorization. So x square minus 34x plus this one will be 240. So let's take 2. This definitely 2 is not equal to 0. So we will take the other thing is equal to 0. Just give me a second, please. Okay, let's continue. So it means that x square minus 34x plus 240 equal to 0. Okay. So what will be the factorization? Factorization will be, here we have a positive. The pair will be below this number. And let's directly check at 25 and 7. 25 and 9. Why 25 and 9? Because 25 and 9 will make 34. Let's check it out. Is the product of 20? No, it's 225. We are very close. Let's move more further away from this 34. So 24. Let's check out 24 and 30 with 10, right? We have to make 34. So yeah, we got the pair. So it's negative 24x, negative 10x, and plus 240. You can implement the quadratic formula if you want. So from the first group, what we can take common? X minus 24. And from here, we have to take negative 10 as a common. So x minus 24. Look, here we don't have to write the positive, and this one will be reduced to 24 is equal to 0. Is this make sense, Isaac?
Yeah.
Is your teacher told you like which next topic she or he is going to start?
Pardon?
Is your teacher told you like which topic you are going to start in the class next after this quadratic equation? Your teacher told you
No, he
what
hasn't told us.
what it is? What's the next topic? I'm just asking that. Is your teacher told you like which topic after this topic you are going to start in the class? Is your teacher
No, he
give
hasn't told
you the
us. I'll
planning?
ask him.
Okay. Okay, might be
No, he hasn't. He hasn't made the plan.
okay. Okay, might be you will start the graph of quadratic equation. So we can start that one earlier. So it will be better for us, like if you find it out. Okay. Okay. These are the two answers.
Yeah.
And these are the possibilities we have for x. So if x is 10, this is a 10. It means that this is a 10. And so 10 and 10, 20. So it means that what's the length then? Length is 24 and 24. Okay.
Yeah.
Does this make sense? No, you can see the
Yeah, a little bit.
okay. Okay, you can check it out again once. Then we will move on to the next question.
Yeah.
Have you done?
Yeah.
Okay, then let's solve the question number 7. And I think one more thing, like if you face any difficulty in any question from your book, so you can share the picture of that question with me on WhatsApp. So I will explain those. Okay.
Yeah.
Here, basically the problem is that I did not find it out your book. I got a different one. I will try again if I will get that one. Maybe it's a different edition. What's the edition of your book?
It's the same as third edition.
Third edition, then why we have a different questions? On which page you are studying like at school? On which page
Let me
you
check
are?
my. Uh,
Okay, bring your book and check it out. Hello?
um, when we did completing the square, we used page 267.
267. Let me reach to that page. 267. No, here we have a 267 is a different thing. It's about the index laws. Oh, here we have. Is this the exercise that you are doing at school?
Yeah, we did it. We're doing something else right now, but that's what we were doing.
Sorry?
That's what we were doing like before we started quadratic equations.
Okay, okay, okay. So in this one, they did not explain the completing square. Okay. So did you complete 6.14 as well? These questions?
No.
Okay, then we can cover this one. Basically, we are already like fluent. You are already basically you are already fluent in this kind of question. Like you can easily solve. So that's why I just moved to this one. Okay, we can practice. I already explained these kind of questions. So solve the question number one. Let's start from question number one. Do you have these questions in your book? Check it out quickly. Do you have these questions?
Checking.
Okay.
Yes, I do.
Okay, then let's solve. Yeah, good. So next time you just have to like tell me the page number, okay? Which page number you are doing at school. So we will practice those questions. So, yeah. Okay, let's practice this one. I already explained this kind of question. If x is subtracted from x square, just focus on the words, what they're saying. If x is subtracted from x square, the answer is 42. It is very, very, very easy. Instead of this one, we will do this question. I think you can easily solve it quickly.
Okay.
Let's see who will solve first. Have you done?
Almost.
Okay. Have you done, Isaac?
Yeah,
What's the answer?
I got 7 and -6.
Seven? Don't you? Okay. Yeah, that's true. I made the mistake at the end. Okay, I solved the next one as well. You can check here my calculation and let me know if this makes sense. Instead of
Okay.
quadratic formula, I prefer here factorization method. You can implement, I will also prefer the quadratic formula because last time I told you quadratic formula implemented on all the questions. On some questions, factorization not work. So that's why I prefer the quadratic formula. But in case like if you get the pair quickly, so in that case, I will prefer factorization if you
Yeah,
know the pair, okay? Because it's short as compared to quadratic formula. Which method you implemented on the last question?
quadratic formula.
Good. Okay. Okay, I solved by using the factorization both these questions. Okay, let's solve the next question together. So B part, you just have to check from here and let me know if this makes sense. X square, we have to add X in X square, and they said that the answer is 306. It's same like the previous question. There is no need to solve it again. It's same like A part. Okay, let's solve the question number 2. Try to solve it. If you face any problem, any difficulty, just check my solution. I'm also going to solve it here.
Yeah. I'm done.
Okay. Okay, then let's move on to the next question. Question number 3. The product of two numbers is 270. The two numbers are these. Find the two possible values of x. It's very simple. Very, very simple. Okay, I will solve here. You just have to check it out and let me know if this makes sense. If not, if you are getting any difficulty, you're not understanding it. So just let me know at that point. I will explain. That's all. Okay. And Isaac, next you have to check out the question number 4. It's very, very easy. And it's your turn.
Okay.
For this right angle triangle, show that 2x squared plus x squared minus 210 is equal to 0. What's the idea? You just have to elaborate
Um,
it to me.
you take 2x squared and then you divide everything by 2. So
No, that's not the right idea. What we need to do here, we have to implement the Pythagoras theorem as this is a right angle triangle, so we can implement the Pythagoras theorem, right? So we can say the square of this side plus the square of this side is equal to the square of 29. Is this true or not?
true.
Okay, then we have to expand this bracket, so it will become 2x. How we can expand? Can you please elaborate it to me?
Um, I'm not sure.
Okay, the identity is this, like if basically you can expand, there are two way. If we have a plus b square, what does it mean? It means that you have to multiply a plus b with a plus b. But this is a little bit lengthy procedure. Like if you are going to solve like this, finally you will get the answer same. A will be times with a and with b. B will be times with a and with b. So it will be a square plus ab plus ab plus b square. Okay. So what we have here, a square plus 2ab plus b square. Does this make sense?
Yeah.
So here instead, basically we want to skip these two steps. Mostly that's why it is known as identity. Like if we have this thing, we can directly write this thing. So here, even you can solve it by using the same technique. But if you want to save your time, so you have to implement the identity. What is identity? Identity says that take the square of the first term, whatever the term is, take its square, plus plus. If we have a plus, so write positive here. Then multiply 2 with the product of both terms, a and b. Multiply these two and then multiply that product with 2. And the add. You have to take the square of the second term. So I'm going to do the same thing here. It will save our time. If you want to do the multiplication like this, so you can also do like 2x plus 1. Again, we have a 2x plus 1. So you need to multiply it. This is a separate thing. And here, you know, 2x square means what it is mean? It means that we have to multiply 2x with 2x, right? And
Yeah.
here same thing, 29 square means 29 times 29. 29 times 29, what it is? It's 841. Okay, no, this one. Here I'm saying again and again, like I will prefer to use the identity here, but I'm not using identity here for just explanation for better understanding. Okay, so look, so it will be 2x will be multiplied with what? 2x, and 2x will also be multiplied with 1, right? And then we will pick 1 and multiply. 1 will be multiplied with 2x, then 1 will be multiplied with 1, and plus this one will be turned into plus 4x square. 2 times 2 will be 4, and x times x will be x square, and 841. I hope this makes sense. 4x square plus 2x plus 2x and plus 1. 1 times 1 is 1, plus 4x square is equal to 841. This is 4x square, 2x and 2x. These are like terms. I cannot add 2x this one with 4x square because these are not like. So plus 4x plus 1 plus 4x square plus 800, oh sorry, is equal to 841. Okay, so look, we are getting the same thing. If you basically by implementing the identity, we can save all these steps. We can save our time that we spent on solving these steps. So what was the identity? Identity says that you just have to take the square of the first term. Let's solve this one now by using the identity. So how identity will work? Just take the square of the first term plus 2 times the first term, the second term, plus the square of the second term. No, this is the second method. Okay, I did not complete it, I knew, uh, but we are just one step far away from the answer. And this thing is 4x square. Here you have to implement the index law, which states that this square will be implemented on 2. It will be also be implemented on x. So 2 square will be turned into 4. X square will be written as it is. And 29 square, it's 841. Here 4x square plus this is 4x plus 1 plus 4x square is equal to 841. It's not that much lengthy question. I'm just explaining by using two methods. Like I'm explaining all the possibilities now, all the ways that you can implement here. I hope you are getting it. Are you?
Yeah.
Okay. So then we have this
A
one
little
and
bit.
little bit. Okay. Okay. Basically, I think I create the confusion because I explained two methods. This is the only question. Just focus on this one. What I did here, just ignore all these things.
Oh, a squared plus 2ab
Yeah,
plus b squared.
yeah. And then this thing is as it is here. It's 4x squared. Like why we prefer this identity? It saves our time.
Yeah.
So that's why I prefer this identity. This is the just question we have. Here I implement the identity. Identity says that take the square of the first term plus 2 times the first term multiplied by the second term plus square of the second term. This is just expansion of the first bracket. up to this point. This is just expansion of the first bracket, and then this thing is written here, and then we have equal. So equal, you can see this is a equal sign. Here we have equal. Okay, 841. This is like, yeah, 29 square. Then I take the square of this one, it's 4x square plus this one will 4x plus 1 plus 4x square. 4x square plus 4x square. So it will be 8x square then, because these are like terms, so we can solve their coefficients. So 4 plus 4, it will become 8. I cannot solve this 4 with this 8, okay, because these are not like terms. 4x plus 1, even 1 cannot be solved with x. These are not like terms. Plus 4x plus 1, and then I take this thing to this side, to the left side. As I will change its side, so its sign will be changed. It was in positive, on this side it will be negative. So then I noticed that I can solve these two terms. These are like, these are constant. So plus 1 minus 40, 841, so it will be negative 840. That's it. Does this make sense? Now we get the quadratic.
Yeah.
So you can implement the quadratic formula, but here I will prefer to take the common firstly. We can take 4 as a common. So by taking in the common, the numbers will, we will get the smaller numbers here. So as we'll get the smaller numbers, it's easy to solve. Like the multiplication will be easy, division will be easy, like whatever we have, the calculation will become easy. To solve 840 times by 8 is easy, or 210 times by 2, it's easy. So definitely if we are dealing with the smaller number, it's easy. So you can ignore this 4, because this is not equal to 0, only the thing which is equal to 0. Or you can say, mostly like most of the author says that you just have to take this 4 to the side. So 0 over 4, it will be 0, it will be eliminated, it will be ignored. So 2x square plus 4 minus 200 and sorry, this was x. 4x minus 210 equal to 0. This is a quadratic equation. You can make the pair, or you can implement the quadratic formula. It's up to you. A is 2 here, B is 4 here, C is minus 210. Just use the quadratic formula. Substitute the values in it. So 2, what was this? 2, 4. No, if we are taking 4 as a common, so nothing is left over there. 1x, right? So B is 1. Is this make sense?
Yeah.
And C is minus 210. So what's the answer is? So we are getting two answer, 10 and 10.5, negative 10. So these are the two answers, okay? Okay, I think that's enough for today. Okay, you just have to check out all these questions. These are easy now. I hope you can solve it. Can you please just elaborate it to me, like how we can solve the question number 7?
Question number 7.
Mhm.
The lengths of two sides of the square differ by 3 centimeters, and the sum of the areas is. So it's gonna be x. The lengths of two sides of the square differ by 3 centimeters, and the sum of the areas. Find the length. So it'll be x times x plus 3 equals 317 centimeters.
No. This is the equation. I just uh, like, here we have a two squares. How many squares we have? Two squares. Both are of different sides, but they mention that if the length of one square is x, the other one's is x plus 3. Okay, if one square's length is x plus 3, the other one's is x. The length difference is there is a difference of 3 in their lengths. So how we can find the area of this square? If definitely if its length is x, its width will also be x, right? So what will be the area of this square? It will be x square. What will the area of this square? it will be x plus 3 whole square. Am I right?
Yeah.
Then this mentioned that the sum of their areas. So these are the areas for both squares. This is the area of first square. This is the area of second square. The sum of both these areas is 317. So this is the equation. So from here you will see x square plus x square plus, if I will expand this one, so it will become 2 times x times 3 plus 3 square b square is equal to 317. Then x square plus x square, it will become 2x square, and this one will become 6x plus 9, and take this thing as well to this side is equal to 0. So this is a quadratic equation. Just implement the quadratic formula on it and get the answer. And this one will be negative 308 is equal to 0. Just use the formula, quadratic formula. What was the value of a? It was 226 negative 308. 2 6 negative 308. This exercise is 6.14. We will verify its answer 6.14 and its question number. Which question is this? Can you please check it out from your book? Which question we solved? It's 6.14, right? 6.17, 13, 14. Which question is this was? We solved question number 7, right?
It's
It was 17, 7. So question number 7,
yeah,
11
question
centimeter
number
and
7.
14. So you can see 11 centimeter, negative 14 is not possible. We will not consider this one. Why we will not consider this one? Because it's negative. So is it possible there is a square with the negative 14, its length is negative 14? Is this possible? No, it's not possible. So it means that there is a one square with the length 11, and there is another square, and its length is 14 centimeter, because the difference is 3, right? So what will the area of this one? Its area will be 121. And what will the area of this one? Because it's this side will also be 14. 14 times 14, it will 196. What will the sum of these two? 196 plus 121. So it will be 7, 2 and 2 and 9. So it will be 11, 1 carry, 317. So it fulfill both conditions. Both conditions. The sum of the areas of both squares is 317, and the lengths difference is 1. The lengths of these squares differ by 1, differ by 3. Is this make sense, Isaac? So like this,
Yeah.
you have to understand the question firstly, then you have to convert into quadratic equation. So yeah, okay, no worries. Here we will practice again these kind of questions in next class. I think still you need to practice this kind of questions, but you can practice this question at home.
Yeah.
Okay, 8, 9, try to practice. Question number 6 you can practice, we did not solve yet. So 5, we solved up to 4. 5, 6, try these questions at home. If you face any difficulty, then I will explain. Okay.
Yeah.